Imagine driving across a massive bridge hundreds of meters above water and suddenly wondering what's actually stopping this thing from collapsing. It's holding up thousands of tons every single day. Cars, trucks, wind, even earthquakes. So why doesn't it just give way? The answer comes down to one thing: incredible engineering. Every bridge is designed to handle forces. There are two main ones you need to know: compression and tension. Compression is a force that squeezes materials together, while tension pulls them apart. A strong bridge doesn't fight these forces, it controls them. It redirects weight through its structure in a way that keeps everything balanced. Let's start with the simplest type: beam bridges. These are exactly what they sound like: flat beams supported at each end. When weight pushes down in the middle, the top of the beam gets compressed, while the bottom stretches under tension. That's why engineers often reinforce beams with steels, so they don't snap under pressure. Beam bridges are simple, but they're incredibly effective for short distances. Now, arch bridges take a completely different approach. Instead of fighting gravity, they work with it. When weight presses down on an arch, the force gets pushed outward along the curve and into the supports on either side. This makes arches incredibly strong. In fact, some ancient Roman arch bridges are still standing today, proving just how powerful this design is. Then there are suspension bridges, the giants. These are the ones that look like they're floating in the air, held up by massive cables. But those cables are doing all the heavy lifting. The road hangs from vertical cables, which connect to huge main cables draped over towers. Those main cables carry the weight and transfer it down into the ground. And here's the amazing part: they're designed to flex. Instead of breaking under stress, they move with it. But shape alone isn't enough. The materials used in bridges are just as important. Modern bridges rely on steel and reinforced concrete materials that are incredibly strong, but also slightly flexible. That flexibility is key. If a bridge were completely rigid, it would crack under pressure. But by allowing tiny movements, it can absorb energy from traffic, wind, and even temperature changes. And yes, temperature matters. Bridges expand when it's hot and contract when it's cold. Without special features called expansion joints, the structure could literally tear itself apart. These joints allow different sections of the bridge to move independently, preventing damage over time. Engineers also design bridges with something called redundancy. That means if one part fails, others can take over the load. It's like having a backup system built into the structure. This is why bridge collapses are extremely rare, because they're designed to handle far more stress than they'll ever actually experience. Wind is another invisible force that can be surprisingly dangerous. In 1940, the Tacoma Narrows Bridge famously collapsed wind-induced vibrations. Since then, engineers have learned how to design bridges that cut through air smoothly, preventing those dangerous oscillations. Today's bridges are tested against extreme wind conditions before they're ever built. And it's not just about building them. Bridges are constantly monitored and maintained. Engineers inspect them for cracks, corrosion, and wear, ensuring they stay safe for decades. Some modern bridges even have sensors that track movement and stress in real time. So when you cross a bridge, you're not just driving over concrete and steel, you're traveling across a perfectly balanced system of forces. Every beam, cable, and joint is working together to keep you safe. Bridges don't stay standing by accident. They stand because of physics, smart design, and constant innovation. And next time you're on one, take a moment to look around, because you're witnessing one of the greatest engineering achievements in the world. Thank you for watching today's video. If you have any suggestions on what I should cover next, please leave a comment down below. If you want to see more bite-sized videos like this one, please like and subscribe. And don't forget to turn the notification bell so you'll never miss a video.